In this video, I'm just going to quickly explore the double bond and therefore the triple bond actually between two carbon atoms in a little bit more detail. We know that when carbon atoms join together, they can be a single bond, a double bond, or a triple bond. In every case, the first bond that forms between the carbon atoms is between a thing called its s orbital electrons. That detail is probably not that important at this stage, but that forms the first bond, which is called a sigma bond. And that's the bond, the stronger of the two bonds in a double bond, and it holds the carbon backbone together. So no matter what's bound out here, there's a sigma bond between the two carbon atoms. In unsaturated carbon compounds, you've got a double or a triple bond. The extra bond or bonds are called pi bonds, and they involve another type of electron called p orbital electrons. So it sort of makes sense, S, sigma, p, pi. This is important because of the nature of the bond. It isn't as strong as the sigma bond, so it's not as strong as the first bond that's formed, but also its electrons are not purely held just in between the two atoms as we show in a diagram like this. It looks a little bit more like this. Excuse me while I slide this up. Just not tried this system. So our sigma bond, our red one, is what you'd expect for a covalent bond in the way that we learnt through our junior school and this year. Electrons are shared, they're shared in between them, and this is how we show them in a Lewis structure. Paired electrons become aligned to represent a covalent bond. However, the p orbitals are sort of a dumbbell shape of space where the electrons are found somewhere in that space, and the pi bond doesn't bring those electrons into here. The pi bond sort of forms like if you can imagine a donut, that was the best analogy I could think of, a donut shape around the two carbon atoms, and that's the pi bond. And if you use that analogy, that model, you can sort of use that to understand why you can't twist or rotate, I should say, any of the unsaturated carbon compounds. Whereas you can with the alkane-based ones where it's a single bond. It can spin because nothing's holding it geometrically in place. Now this becomes important because with those electrons not being in here, but actually up here, and at the same time here in three-dimensional space, here, and then behind it, because they're in a different space, then they're actually more free to be moved if there's enough of an electric force, for example. And this becomes important when we look at what's called a conjugated system, where we've got alternating double and single bonds, and that will be the next thing. So just a quick summary. In a double bond, you've got actually two different types of chemical bond. They're both covalent bonds. The sigma bond is the first one to form, and it is the strongest one. It's the one that is where the electrons are shared between the two, and it creates that relationship, that carbon backbone, the relationship between carbons or carbon backbone. The second bond, and therefore the third bond as well, they're called pi bonds. So the second bond that forms between the carbons is called a pi bond. Its electrons are arranged slightly differently in space, and so therefore they can have some slightly different properties. And I've tried to represent that with this diagram here. The sigma bond electrons are directly in between the two carbon atoms, whereas the electrons that form the pi bond are in a space around it, generally thought of as above and below at the same time. And as I say, that will become important shortly when we learn about conjugated systems.